Okay, so guys, this is the third example in this chapter of internal forces. Now here I have a distributed load from A to B, and then I have a loading at the end of the beam. Now guys, I want you to know that any loading at the end of the beam, like this case, even if it is a moment or a force, will not affect the equation of V and M if you are always taking the left part. However, guys, it will affect it implicitly from the reactions, because in fact the reactions here are directly affected by these loadings. Okay, so because I'm taking the whole beam as my free body diagram whenever I want to find these reactions. So the reactions value are affected by these loadings. However, guys, when you find the equation of V and M, if you are always taking the left part, you can see that they will not be included explicitly, but they are included implicitly by the values of the reactions. So how many cuts do I have here? Of course, I should do a cut on the distributed load and a cut here after the distributed load, and you can, guys, do it by yourself, and you can find here the shear and moment diagram. And whenever, guys, you find that it is hard to draw like this example, the moment, but you know the equation of the moment, take some particular values, all right? But be sure that this particular value lies in the interval of your x. So for example, here, x is between 8 and 11, m is equal to 20x minus 370. So you should take some particular values lying between 8 and 11 in order to draw this line, for example. And here, if I have a second degree equation, I also have to take some particular cases to draw this curve here and make sure that this particular case, this particular value of x lies in the interval of x. Now, what if I have a fixed support instead of a simply supported beam, like a cantilevered beam? So can I find Vm and N if there is N? Yes, of course, guys. First of all, like this case, you should find all the reactions at this fixed support. Now here, since I have an oblique reaction P2, this means that I will have AX, all right, because AX will be the projection of P2 in X direction. So the first step is to find the reactions. I can find AX, I can find AY. What is AY? AY will be also equal to P1 plus the projection of P2 on the y direction. Of course, I should give you here an angle. So this is how to find AY. And then I should find MA. How to find MA? By doing the sum of moment around A. So you should know also the distance from each force to A, and then you can find MA. So this is how you can do the first step. Now I know the reactions. Don't forget that for the fixed support, I have a moment reaction. This is a very important note. And then, guys, I should do my cut. So how can I do this cut? Basically, I should have two cuts. First cut should be between A and P1, and the second cut, of course, will be between P1 and P2. So why, guys? I want to show you this example because I want you to make sure that whenever you are finding m of x, you should include also ma. So don't forget this moment reaction. For example, if I take the first cut, then this should be my v, this should be my n, and this should be my m. And I want to find the bending moment mb. mb basically, guys, will be equal here to minus ma, okay, because they have the same direction. Alright, now if I do the second cut, which is here, basically MB will be also equal to minus MA minus P1 times this distance right here, which is basically X minus the location of P1. So this is only, guys, to make sure that if you have a fixed support, you should include the moment reaction at this fixed support in the equation of bending moment. Thank you.